I will be presenting the paper Contextualized Weak Supervision for Text Classification, which was published in 2022 in AAAI. I will follow this order for my presentation. First, I will be briefly talking about the subject of this paper. Weakly supervised text classification has gained popularity because it elevates the need for extensive manual annotation by human experts. These weakly supervised methods for classification are based on using user-provided seed words. However, existing methods generate pseudo-labels in a context-free manner, this type of manner overlooks the context-dependent nature of human language. If we give an example, for the word penalty, there are at least two meanings. One is sport-related and one is law-related. If the pseudo-label of a document is decided based on only the frequency of seed words, which is how it is done in typical methods, some documents about law may be mislabeled as sports. So to solve this type of problem, the framework here you can see in figure 1 is proposed in this paper. The framework describes the framework leverages advanced techniques like Elmo and BERT along with user-supervised seed information to create a contextualized corpus. This corpus is then used to train a classifier and expand seed words iteratively. During this process, seed words are expanded and clarified using contextual information, and each word's interpretations are determined adaptively and occurrences are grouped based on their contextual representations. This iterative process continues until convergence and improves the classification model with each iteration. And this framework is the first work on contextualized weak supervision for text classification, and experiments on real-world datasets demonstrate the superiority of the framework, especially when the labels are fine-grained. The literature is reviewed in 4 categories: weak supervision for text classification, contextualized word representations, word sense disambiguation, and document classifiers. This paper focuses on using user-provided seed words as the source of weak supervision. The methods that are shown here use weak supervision too, but all of them follow a context-free manner. And for contextualized word representations, KEBELI generates contextualized representations for a word based on a pre-trained MT model. And there are more popular contextualized word representation techniques like Elmo and BERT too. And the proposed framework is compatible with all of the mentioned representation techniques, but they used BERT in their implementation. And word sense disambiguation is the process of identifying which sense of a word is meant in a sentence, and it is a challenging problem in NLP. Typical WSD models are trained for a general domain and they require additional annotated training data when we apply it to a specific corpus. However, the proposed technique here is adaptive to the input corpus and doesn't require any additional human annotations. And lastly, for document classification, even though most classifiers are compatible with the framework, they chose to use Han in this paper. Han considers the hierarchical structure of documents and finds the most important words and sentences in a document. Now, if we look at the problem in our hand, we have n number of text documents and m number of target classes with their respective seed words. So there are m classes for seed words and n number of documents. And the aim here is to build a classifier that will assign these class labels to each of these documents. Both the corpus and the seed words are contextualized in this framework. Corpus contextualization is done by using BERT. to create the contextualized vector of every word occurrence. And seed word contextualization is done by using a comparative ranking method to select highly labeled indicative keywords to further better the choice for seed words. Here, if we give more detail about this process, they start with all possible interpretations of seed words and train a neural classifier. Based on the predictions, they compare the documents from different classes and rank the contextualized words to eliminate the wrong interpretations on initial seed words and add more highly labeled indicative contextualized words. Here, this process can be seen in this figure, and here the only hyperparameter that we have is the number of iterations between classifier training and seed word expansion, which is shown as T. We will see it again later. And for the methodology, for a given word W, all of its occurrences can be shown like this, and N is the total number of occurrences in the corpus. BERT is used for generating the contextualized vector, and for easy computation, they normalize it into unit vectors. Here, the B sub WI is the contextualized word representations, which are the vectors. And cosine similarity is used to measure the similarity between two vectors in the contextualized vector space. If two word occurrences of the same interpretation are expected to, two word occurrences generally have a high cosine similarity between their vectors too if they are from the same interpretation. And for the word occurrence ambiguation problem, they model it as a clustering problem, and K-means algorithm is used to cluster all of these representations into K clusters, where K is the number of interpretations. Here, why they used K-means for clustering is because, first of all, cosine similarity and Euclidean distance are equal for unit vectors, and in our case, the vectors are unit also. And the distance metric for K-means algorithm is Euclidean. And the second reason is it is fast, and they are clustering a significant number of times in this framework, so they chose to use K-means algorithm. The value for K is purely based on tau. Tau is the similarity threshold. And if the cosine similarity between two cluster center vectors is bigger than tau, it means the two clusters are related. We need to increase K while making sure there are no clusters that are too similar, and tau is used to make sure this condition holds. But in practice, this K value is usually no more than 10, and it is increased until the constraint is violated. Tau is picked based on user-provided seed information instead of hand-tuning. We can do this because they make two major assumptions at the beginning of the paper, that for any, the first one is for any seed word, the majority of its occurrences follow the intended interpretation by the user, and the second one is the majority of the seed words are not ambiguous, which means that they only have one interpretation. If you make these assumptions, we can choose tau based on the user-provided seed information. For each seed word S, the median of pairwise cosine similarities between its occurrences are taken, and then the median of these medians are taken as tau. So here we can see an example. In one of these data sets used for the experiments, there are two interpretations for the word windows. They first compute the pairwise similarities between all its occurrences and find the median, which we can see here is 0.7. They do the same for all seed words and find tau as 0.82. Then we can increase K according to the constraint rule for the word windows, and it ends up at 2. So K equals 2. And we can see the visualization of its K-means clustering results here. The interpretation of each occurrence of W is decided by the cluster ID to which its contextualized representation belongs. And by applying this equation here, equation 4, to every word and their occurrences, the corpus is contextualized. And here the pseudo labels and the classifiers that are used are not the focus of the paper. So pseudo labels for unlabeled contextualized documents are generated, and the classifier is trained based on these pseudo labels. Similar to other weakly supervised methods, they did not provide any novel idea for this section. Pseudo label generation is done by a simple counting method. Here, term frequency of the seed word SI from SC is calculated, and we sum them up, and each document gets a label based on the words it contains the most from the seed words. And document classification, again, there's not a new idea for this section, but they use Han, and it is trained on contextualized corpus with the generated pseudo labels, and the predicted labels are used in seed expansion and disambiguation. Here, so far we contextualized and the documents and their predicted class labels. Now we have to expand or eliminate the initial seed words to make it better. And an ideal seed word in our case is an unusual word that appears only in the documents belonging to that label with significant frequency. And to make sure these seed words are right, they built a ranking score based on 3 features. First one is it has to be label indicative, and they calculated with this formula. It needs to be frequent. It is calculated by this formula. Actually, they are using tan-hash, the hyperbolic tangent function here, to scale the unbounded frequency value. And lastly, it needs to be unusual, so they are using inverse document frequency for this. And the final ranking score is calculated as the multiplication of these 3 values. And when we do this, they add the top few words to the seed word set, and they ambiguate some seed words based on this ranking too. Now I will be sharing the experiments and the results. The experiments are done on both coarse and fine-grained text classification tasks. 2 news data sets are used in this experiment. One is the New York Times, and the other one is the 20 News Group. For New York Times, there are both fine-grained and coarse-grained classes, and this data is imbalanced in both of the classification tasks. And the 20 news data is imbalanced only in the coarse-grained classification. So that's why they use micro and macro F1 score because of the imbalance to see the performance. Here the experiment settings can be seen like this. There are 6 methods to compare the Convia architecture, and first one is IRTFIDF. The relevance of a document to a label is computed by aggregated TF-IDF values of its respective seed words in this framework, and the label with the highest relevance is assigned to each document. Dataless gets the vector representation of labels and documents from Wikipedia. Word2Vec learns the vector representations and derive a label representation by aggregating the vectors of its respective seed words. Dr. Cube, we mentioned, that was already also in the literature review part. Label names are the seed set, and multi-dimensional document classification by learning dimension-aware embedding is performed. And West class is generated pseudo documents are used as the seed information, and the model is improved by continuously learning from real unlabeled documents using a self-training process. And lastly, there is a supervised model to compare the architecture, which is unsupervised. They use this to see how much the unsupervised settings can hold up compared to the supervised settings. And there's 3 ablated versions of this architecture. The first one is without the contextualization of corpus. The second one is without the seed expansion model. And the third one is contextualization module is replaced by LESC algorithm, which is a classic word sense disambiguation algorithm. And we can see the performances of each method here. And we can see the need for contextualization is even more important for fine-grained classification, because in the fine-grained results, the other methods results do not even compare to the proposed framework. Once the corpus is contextualized properly, the subtle ambiguity between words is a drawback to other methods, but in this method, it can distinguish them and predict them correctly. And effectiveness of seed expansion is shown through the ablation method here, this one. In all of the cases, it improves the seed expansion module, improves the result. And the other 2 ablation studies shows the effectiveness of the proposed methods, contextualization. And the proposed model actually shows similar close performance to the supervised method. Here we can compare it with unsupervised 2, which is closing the performance gap between the weakly supervised and supervised settings. Here for the parameter study, as I mentioned, the only hyperparameter in the algorithm is t, and which is the number of iterations of iterative expansion and classification. To decide which value for t is the best, there's this visualization that we can see. Performance increases initially and converges gradually after 4 or 5 iterations, while there is some fluctuation after the convergence point. A reasonably large t value, like t equals 10, is a good choice. And the number of seed words is also important. And performance increases with the number of seed words as expected, but there's a slightly different pattern on 20 news dataset with fine-grained classes. Here we see a decrease different than the other graphs here. But it is probably caused by the subtlety of seed words in fine-grained cases. Additionally, seed words may bring some noise too. So overall, the number for seed words per class is decided as 3, and it shows that it's enough for reasonable performance. So in summary, the framework leverages contextualized representation techniques and seed words to contextualize the corpus. This corpus is used to better the interpretation of seed words and document classifier training. And for future work, this method can be adapted to solve the hierarchical text classification problems too. And the proposed method can be extended for other types of textual data, not just news, but such as short text and multilingual data. And this is the presentation. Thank you for listening.